Hello students, today we will solve a question based on electric dipoles. Okay, the question goes like this. The 2-point charges Q1 and Q2 of magnitude plus 10 to the power minus 8 coulombs and minus 10 to the power 8 coulomb respectively. Q1 is having magnitude of plus 10 to the power minus 8 coulomb and Q2 is having magnitude of 10 to the power minus 10 to the power minus 8 coulomb. Okay, are placed 0.1 meter apart. Calculate the electric field at point A, point B and point C. So we have to calculate the electric field at point A, B and C. So kindly come to the diagram and follow up the red ink. See, here we have B, here we have A and here we have C. These are the points in red which needs to be calculated for electric field. For knowing the electric field. Okay. Now where we have placed our charge is, one is over here, see Q2 is here, whose magnitude is minus 10 to the power minus 8 coulombs, and Q1 is over here, follow up the green ink, that is plus in nature and it is equals to 10 to the power minus 8 coulomb. So what do you understand by the charge configuration? We understand from charge configuration is that on a single line at one end we are having a negative charge and on the second end we are having a positive charge and both are having same magnitude equals to equal, hence they construct a electric dipole. Hence it is a electric dipole. Okay, electric dipole is something where there is two charges system and the charges are having same magnitude but the polarity of charge is different. One should be negative and other should be positive to construct a electric dipole. Now first of all we will understand from the diagram which point is affecting where and which point is forming electric fields where, so that when we start our solution we can simply go to the given formula, apply the given values and find out the electric field at the given point. Okay, for doing so follow up the purple ink. See, from this A our electric field will go from positive to negative, that is the movement of or the direction of electric field, direction of electric field. Okay, from positive to negative. So here this is the direction of electric field. Now we will look at B. Okay, so what is happening in the case of B? Positive charge is over here, negative charge is over here, and hence the distance between this is approximately 1.5 meter. Okay, that is 0.05 meters, then 0.05 meter. It should be around 0.15 meter, not 1.5. Distance is 0.15 meter. Okay, now from this point B, electric field is moving towards the B only. it is coming out from the positive. Now, due to C, what is happening? See in this diagram, due to this negative charge, field will be attracted to it. Field will be attracted to it. Field will be moving away from the positive charge. Follow the blue linings. Field moves opposite to positive charge and field moves towards the negative charge. So see over here, this is our negative point. Okay, this will attract the field. The field will come in this direction from C. Okay, this is our positive charge. The fields will go in this direction. Okay, so we will find a field in this direction, a field in this direction, which are nearly like 120 centimeter apart. Two vectors we are getting, they are 120 centimeter apart. They are making an angle of 120 degrees. So what next step we will do? We will find a resultant of it. What we will do? We will find a resultant of it. Okay, this is electric field resultant. This is electric field resultant. How we will find electric field resultant? Using our parallelogram law of addition, we will find the resultant electric field. Hopefully you have understood the diagram. Now we will move towards the solution. Okay, follow up the reading. This is our solution. Okay, so first of all, electric field at A. Electric field at A, due to positive charge, will be directed towards right. Because we have a positive charge here, fields will go in this direction. So we know the field equals to F divided by Q. What is the value of F? F is K Q square divided by R square, which is divided by Q. We will get K Q square by Q into R. This square will get cancelled, this square and this Q. What we will get is K into Q divided by R square. K into Q divided by R square. Okay, so see here, what is the formula we got? We got the same formula which we have derived over here. See the derivation of the formula over here. We got the same. Value of K is, it is same for everywhere, that is 9 into 10 to the power 9. That is a constant. Value of Q is given as, see, Q is given as 10 to the power minus 8 coulombs, and R square is the distance. So what is the distance between our A and the negative charge? A and the negative charge. A is here and our negative charge is over here, that is 0.05. That is 0.05. Okay. So we will get, after substituting all these values and after doing calculation, the value of electric field which we will get is 3.6 into 10 to the power 4 Newton per coulomb. Now due to negative charge, it will be directed towards right. This will also affect, okay, first because of this positive charge from A, it is affected to this side. Now due to this negative charge also there will be affection. Okay, so similarly we will get the same value of electric field, that is K Q by R square, and K is same, Q is same, and the distance between the negative and this A is also same. Positive and A is also same. Distance from positive charge to A is equal to negative charge to A ka distance. Okay. So everything is same and hence the electric field which we received is also same. Now the total electric field at A is A due to positive charge, electric field at A due to positive charge and electric field at A due to negative charge. Adding up both the electric fields, we will get 7.2 into 10 to the power 4 Newton per coulomb. That is the electric field at A due to positive as well as due to negative charges. Okay, moving on to the next slide. Now electric field at B. So we have already seen where is the point B, and it will be extending out from our positive charge towards the left side and due to negative charge towards the right side. Full of the blue ink, I will draw the diagram here in the right corner. Okay, so this is the point B over this line. This is B and our positive charge, our negative charge. Due to this negative charge, it will be like this: E due to negative charge and E due to positive charge, away from the positive charge, E due to positive charge. Okay, see what is written over here: electric field at B. Due to positive charge, it will be directed towards left. Okay, so just always this is our right, this is our left, and due to positive charge it is directed towards the left, and due to negative charge it is directed towards the right. See, towards the right. Now this is our positive charge, this is our B. The distance between both of them is 0.05, and distance between a positive and a negative is 0.1. Okay, so what is the total distance between B and negative charge? This is B and positive charge. B and negative charge में कितना distance है? It is addition of both the distance. Okay, that is equals to 0.15 meter. Okay, so this is here, it is given. Now let us understand how we have substituted these values. Our E due at B due to positive charge, I'll write over here with the red ink so that it will be easy for you to understand. See, electric field at B due to positive charge. Okay, that is kq by r square. Q is 10 to the power minus 8 and r is 0.05 ka whole square. So we have got this answer. Now this is electric field. I will write electric field as E vector at B, same point, okay, due to negative charge is towards the right side, and the distance from B to the negative charge from B to the negative charge is 0.15, the whole square, and hence we will get a answer of 4 into 10 to the power 3 Newton per coulomb. Now the total electric field at point B is given by E at B due to positive charge, E at B due to negative charge. Okay, and what we are doing here is we are subtracting the two fields. I will write it with purple color. Make a note of it here. We are subtracting the two field, subtracting the two fields. And why do we need to do that? In the previous case, we have added the two fields. Why in our second case we are subtracting? The answer is very simple. See, this is going in left direction. This is going in right direction. So whenever two things are going in opposite direction, how can we add them up? The resultant will be the subtraction of the two fields. So I'll write the justification here as the fields are moving in opposite direction, they are being subtracted to find the resultant. Okay. Now the third case is electric field at C. Where was C? C was here. One field will come from positive charge, one field will be due to negative charge, which will go to the negative charge. For positive, away from charge, negative towards charge. Okay. So we will get a field like this and like this, making an angle of 120 degrees, and the resultant will be in between them. This is resultant. Okay. So due to positive charge, it will be alone DC. Alone DC implies this. Okay. And we will find E E at C due to positive charge equals to KQ by R square, as the triangle which was made was like a equilateral triangle. So this side DC or CE is same, 0.1 meter, 0.1 meter. Okay. So we will substitute the value over here, calculate it to get the electric field magnitude. Then see the other statement here, due to negative charge will be alone CE. This is CE, positive, negative. This is CE, CED. Okay. So this is also, what is the magnitude here? 0.1 meter, same magnitude. Okay. And again we will write electric field at C due to negative charge equals to KQ divided by R square, equals to 9 into 10 to the power 9 into 10 to the power minus 8 divided by 0.1 the whole square, and it will be valued to give us 9 into 10 to the power 3 Newton per Coulomb. So see this last line, which will give you a very important fact here. Since these two field lines are directed along an angle, the fields will not cancel each other. Resultant will be directed towards the right. See, I have explained you in this diagram. We will take as per to our convention this as left and this as right. Okay. So moving on to the next step. See over here, we are having E resultant equals to E at C due to positive, E at C due to negative. So both the E at C due to positive charge was equals to E at C due to negative charge, and that was 9 into 10 to the power 3 Newton per Coulomb. Okay. So this is our additions law. Addition law. In this particular graph, where in this particular diagram I have explained you, this angle was 120 degree, which we have used here in this equation. What is the original equation? It is ER equals to E1 square plus the whole thing is under the root, okay, plus E This will be equals to E2 square plus 2 into E1 E2 into cos theta. So let us understand the value of all these different things. E1 is this. Okay, this is our E1, this is our E2, and what is theta? See here, the angle between E1 and E2 is theta. Okay, angle between E1 and E2 equals to theta. Okay, now further solving, what we exactly get it is that E resultant, I'll change the color of the pen, E resultant equals to 9 into 10 to the power 3 whole square. This whole thing is under the root, okay, plus 9 into 10 to the power whole square plus 2 into 9 into 10 to the power 3, again it will be whole square because E1 equals to E2, and then cos 120. Okay, so how we will solve cos 120 is cos 120 will be written as cos 180 minus 60. Okay, cos 180 is pi by 2 minus cos 60 is how much? Pi by 3. Pi by 3. Anything, this is a trigonometric formula. Cos pi by 2 minus theta equals to cos of minus theta equals to minus cos theta. Okay, so this will turn out to be cos of minus pi by theta, like pi by 3, and it will be cos of pi by 3. This minus we can take it out also, it will make no difference. Okay, now cos of pi by 3, what is the value of that? Cos 60 का value क्या है? It is 1 by 2. Okay, substituting again this given values, this and this will get added up and it will be 2 into 9 into 10 to the power 3 plus 2 into 9 into 10 to the power 3 into minus of 1 by 2, and the whole thing is under the root. Okay, ER, that is resultant. This 2 will cancel out with this 2 and this minus will make this positive sign is minus. Now 2 into 9 into 10 to the power 3 minus of 9 into 10 to the power 3 under the root. So what is the value of 2a minus a? It is simply a. So 2 into 9 into 10 to the power 3 minus 9 into 10 to the power 3 will give us a value of 9 into 10 to the power 3. And yes, we forget one thing, that is squaring all these values. These all values are squared in nature. Okay, already squared. I have forgotten to take the square. This value 9 into 10 to the power 3 is squared. Okay, so 2a square minus a square will give us only a square. We get this value, that is under the square root. So under the square root, how can we write under the square root? We can write like, if we are having a square under the square root, we can write it as a2 upon 1 by 2, which will give us a2 into 1 by 2. 2 will cancel out. What is the left thing? That is a. So similarly we will apply this thing over here and the final answer we will get is 9 into 10 to the power 3 Newton per coulomb along right in this direction, along the direction right. Okay, in this direction. See the purple graph, purple diagram in this direction. Okay, so that is how we will find the electric fields when we are given an electric dipole. So always remember, the most important point which will lead you to the perfect answer is that from a positive charge, electric field lines moves towards the out, and from a negative charge, these electric lines come nearer. They try to get attracted to the negative charge and they try to move away, very away from the positive charge. Okay, just you can correlate this concept like whenever your mother cooks a very healthy meal for you of palak. Okay, she made palak juice for you. How will you drink it? With a happy face or with a very sad face? You will like, अरे ये क्या दे दिया मुझे? Okay, so that is a positive thing. If you will have spinach juice, it will increase the immunity in your body, the RBCs in your body and whatnot. But still you are not happy to take it, right? So when it comes to the positive charge, these electric fields tends to move away from it. But whenever it comes to the negative charge, junk food, mom got a packet of pizza for you. How much happy you are? Oh, there's no boundary. It's in infinity, right? You are too much happy. So same happens with the negative charge. All these electric field gets attracted to the negative charge. They moves towards the negative charge. Do not use word attraction or repulsion when you are dealing with the electric charges. It is just for you to understand. Always use towards and away. When it's a negative charge, these electric fields are moving towards the negative charge, and when it is a positive, these electric field lines tend to move away from the positive charge. Okay, that is the movement, not attraction, not repulsion. It is not a proper that kind of property. It's a property of the motion, how these are moving, in which direction these are moving. So once you know from which direction to which direction electric fields are going, you can solve any kind of complex situation whenever you are dealing with electric fields and directions of electric field. Okay, that's all for the today's class. Hope you got the question, and these small kind of tricks which I try to deliver to you is very much clear to you. So thank you and bye bye.